Hello, I'm Nakov from SoftUni, the software university. Together with my colleague George Georgiev, we shall teach this free Java Foundations course which covers important concepts from Java programming such as arrays, lists, methods, strings, classes, objects and exceptions, and it prepares you for the Java Foundations official exam from Oracle. In this lesson, your instructor George will explain and demonstrate how to use lists in Java, how to allocate the list using the ArrayList generic class, how to access list elements by index, how to add, modify, insert and delete elements from a list, and how to read, traverse and print a list. Lists in Java are like arrays. They hold an indexed sequence of elements of the same type. But unlike arrays, lists can resize. In this tutorial on Java arrays, along with the live coding examples, your instructor George will give you some hands-on exercises to gain practical experience. Are you ready? Let's start! Before we dive into the course, I want to show you the SoftUni judge system, where you can get instant feedback for your exercise solutions. SoftUni Judge is an automated system for code evaluation. You just send your code for a certain coding problem and the system will tell you whether your solution is correct or not and what exactly is missing or wrong. I'm sure you will love the judge system once you start using it. Let me show you how you can submit the solutions from your hands-on practical exercises to the automated grading system, the so-called SoftUni Judge. So you have a judging system designed to send you your code and it tells you whether the code is correct or not, and I will show you how it works. You open this link and you go on this website where is in the SoftUni Judge, and you click practice, and you have this Java full foundation course. These are the problems, and here you put your code just like it's shown here, and you submit and you send it. So for example, the first problem, student information, is this one, and this is your solution in Java, and you want to check whether your solution is correct or not. You click submit and it appears here. So you can refresh in a few moments and it tells you whether your code is correct or not. If you put some incorrect code, for example, I will format incorrectly the age and the grades of the output, and when I click here, it tells me that I have all the tests wrong, and in this case I can click the details and I can see that the expected input is like this, and my output is this one at the right. I have one additional digit which should not be there. So this is how the judge system works. It will be your best friend when you are learning Java through our training courses, because as I repeat many times, learning Java is mostly coding and less watching videos. So you need to practice. That's why we have prepared a lot of coding exercises for you, and please do them because I want you to become Java developers. Before the start, I would like to introduce your course instructors, Nakov and George Georgiev, who are experienced Java developers, senior software engineers, and inspirational tech trainers. They have spent thousands of hours teaching programming and software technologies and are top trainers from SoftUni. I'm sure you will like how they teach programming.
Hello everyone, my name is George and I'll be happy to introduce you to the topic of lists in today's lesson. So, what are we going to talk about today? Well, as I said already, we're going to talk about lists. Now, what are lists? By this point, you already know what arrays are. So, lists are just a variation of arrays, which allow us to do some neat stuff, and I'll show you how we can do that stuff. First off, we will see what lists are as an overview, we will see their functions, we will see how we can modify them, we will see what they have in common with arrays and how we can use them the same way as we do arrays, but with some additional features. Then we will talk about how we can manipulate those lists, remove elements from them, resize them, and so on. Then we will start talking about how we can read lists from the console and how we can print them on the console, just like we have done with arrays. And a new topic, which will be somewhat different than what we've seen already, will be what sorting is and how we can do that to lists and how we can do it to arrays also. So, the topic of lists. First off, before we start with what we need to study itself, let's talk a bit about what we already know. So, let's get an IntelliJ IDE here and see what we have currently in our knowledge base. So, by this point, we have created arrays. What is an array? An array is a sequence of elements which have indices and which have a size, a number, a length. So how do we create an array? We say what data type we want, and then we write the identifier of the array. So let's say we have an array of words here. We will create the array words. And I'll say that this array is initialized by a string array, which contains the elements hello, hello, and world. Okay, and let's format this with Ctrl-Alt-L. And I've got this words array here now initialized. Okay, so what we know we can do with these arrays is get elements of them, set elements of them, and also we can iterate the elements given the length of the array. Otherwise set, we can say do a for loop starting from I equals 0 to words.length. Okay, so these are the properties we have of arrays. We have their length and we have access to their elements using this operator with the square brackets. We can say words square brackets I, and we can tell this element to get a value set to it, or we can use the value of this element and, for example, print it to the console. Okay, well, since we can do these things, how can we tell this words array to increase its size? For example, we want to add another word to it, like the word buy. How would we do this? Well, if we just add it to the initializer, that's okay. The array will become 3 elements. But what if we want to get this words array to 3 elements after we've initialized it? So let's say we've done something with this array, like the code we had here. Let's say we just printed it to the console here. System.out.println will print each of the elements of this array due to the for loop on the console. And let's say after we initialize this code, we want, after the print step, to change the size of this array. Let's say we want to add 1 element to it. How would we do that? Can we do that in Java? Well, the answer is no, and the answer is no not only in Java, but in pretty much any other programming language that has the concept of arrays. Arrays are sequential bytes of memory. They always will contain sequential bytes of memory in the RAM of the operating system. So if you have an array, you can't really extend it. Why can't you extend it? Well, let's say we have, let's say this blue rectangle represents our array, our RAM memory, our operating memory. And let's say we want to create an array in it, like we have now, which has the words hello and world in it. And let's say we want to take up some additional space here. Let's say we want to take up space for an additional string. How would we do that? Well, we can't. Even though we know which byte is directly after our array, we can't be sure that some other program hasn't taken up this space already. Meaning that, for example, PowerPoint at this moment could be hogging up this part of memory, and we can't just extend our array into that part of memory because we would eat up PowerPoint's memory, or whatever other program could be executing there. And even if no program is executing there, that's not something our program can know. Consequently, we can't afford to optimistically take up memory right after our array. So programming languages don't have the ability to resize arrays. They can't extend them and they can't reduce them, because what would happen if we have a sequence of memory, an array in the RAM memory of our system, and we decide to delete the element in the middle. Well, the array won't be consecutive anymore unless we do an operation in which we move each of the following elements one index to the left or reduce their index by one. The array won't be consecutive. So you can't really resize an array. Now what you can do, since you can do anything with programming, if you know what arrays are and what loops are and what conditional statements are, what you can do is create a new array and copy the elements from words into that new array. So what I mean is you can create a new string array, let's call it string extended, and create it with a size that is one larger than the size of words, i.e. we can say words.length plus 1. Okay, and then what I do is I'd start a for loop starting from 0 and continuing on to words.length, not to extended.length, because I want to access all of the elements of words. And I'd say extended at position I, set words at position I. Now what happens at this point? Well, we have an extended array that contains 3 elements, well, 4 if we don't delete this by we add it to the initializer in words. Okay, so we have this extended array, it has 3 elements, whereas the words array has 2 elements. So this is our words array and this is our extended array. So extended array will now have the elements of words copied into it, and it will have an additional empty space which will contain the no string, i.e. it won't contain anything. And we can use that space to add the value we want. For example, if the task we have is read a string from the console and add it to your array, this is how we do it. So we'd read a string from the console, for example, let's call it input, and we'd say create a scanner and tell the scanner to read the next line and tell the scanner to read from system.in. And I'd say extended, set the last element. How would we set the last element of extended? Well, we will get extended.length -1 and set that to input. Okay, and once we've done this, extended contains a copy of words, and its last element is what we've read from the console. And now, after we have this extended array, we can simply say words equals extended. What will this do? Well, that will say the words variable will now point to the memory that was allocated for extended. So both extended and words will point to the same memory, and effectively we've increased the size of words. Although we haven't really increased it, we've just created a new array and copied elements into it, and that array is one element larger. So that's how you add elements to an array. If you want to add an element to an array, you have to create a new array, copy each element of the old array into the new array, and then add whatever element you want to the end of the array, and then tell the array, the original array, i.e. rewrite the original array to point to the memory of the extended array. And now if you want to create a method for this, let's say this will be a parameter here, the input, and we'll call it item to add. We can now come over here, mark this code, press Alt R, invoking the refactor menu, press X, invoking the extract menu, and press M, invoking the extract method function, and say add item. Now what happened here, I didn't mark the part which adds the item, hence that wouldn't have been the full code I wanted. So let's do this again. I'll say add item. The first parameter of add item will be the array to which we want to add an item, and the second parameter will be the item which we want added. Okay, so what will IntelliJ generate from this? Well, we'll have an add item method which will return a string array, and we can now just simply say, instead of creating an extended array, we can simply say words equals add item of words, item to add. Or we can simply copy this item to add, copy this code directly into the method. So what we did now was create an array, initialize it with 2 items, and then create a method which takes the array, generates new memory for it, copies all of its items into the new memory, and then adds a single item to it, and returns the array that was created. Okay, so this is how you add an item to an array in one line of code. Of course, it isn't exactly one line of code, it's a method which we had to implement. Okay, in addition to the fact that we had to implement it, there's another problem here. Say that you want to add a lot of items. You don't know how many. You will, for example, the task will be read items from the console, read strings from the console until you reach the string end. Well, what would we do in that case? Well, we would do a while loop. While what? Well, we will need to read the input. So we'll get the scanner we created over here, and we'll, instead of reading directly from it, we'll save it into a variable. We'll just say scanner equals new scanner reading from system.in. And with the scanner, we'll read a new line, save it into a line string variable, and we will say until line becomes end, the string end, so until line dot equals the string end, but we don't want it to be equals, we want the while loop to continue until we have a mismatch here, meaning that meaning we want while to execute if the string isn't end. So the task, let's reiterate the task, we will have input which looks like this. We will have lines which will contain words, for example, word 1, then hello, then goodbye, then what's up, and then we will have end. Our task is to read all of these words. We don't know how many of them there will be. We just need to read all of them and, let's say, reverse them, print them to the console reversed. How would we do that? Well, let's see. We have a line here which we're reading from the console, and we're going to say until the line equals end, meaning continue if the line doesn't equal end. So if we read a line and that line is word 1, that doesn't equal end, so we need to get into the while loop. Okay, so what will we do now? We will say words equals add item, words, and the line we just read. So what this loop will do, it will read line by line. Oh, and we'd also need to say line here, again, equals scanner.nextLine, meaning read the line, read the next line, and then read the next line, and then read the next line until line becomes equal to end. Okay, so read line by line and add items to words. Okay, and what we also said is we want these words printed in reverse. And let's remove this initialization of words which we used for the example. We will just have words become a new string array of 0 elements. This is also possible. You can create arrays of 0 elements. Usually you wouldn't do that because you can't write any elements in them. But in our case, where we don't know how many elements we're going to be adding, we can create an array of 0 elements and start extending it through the addItem method. Okay, so we have the code that reads item by item from the console, i.e. line by line from the console. And now we have to just print our words array onto the console. So we'd start a for loop, or we can just say words, out and enter, iterate, and this will generate a for loop for us, a for each loop in Java, which will pass through each word of the words array. And now we can print this word on the console. And now you'd say, okay, but George, you said we want them printed in reverse. Okay, so it won't be a for loop. It won't be a for each loop. We will just replace this with an indexed for loop. You can do that from IntelliJ. You can say out and enter on the for loop, and then select replaced for each loop with indexed for loop, and this will generate an indexed for loop. And we want not to iterate the array from start to finish. We want to iterate the array from finish meaning from the last element, which is at index length -1, to the first element, which is at index 0. Okay, so here we get the word, and now we want to print the word. And let's say we want to print it on the same line with a space after it. Okay, so what will this code do? Well, this code will execute as many times as there are lines that don't contain the string end in them, meaning that aren't equal to end, not just contain. So if we have friend, this will continue to execute. Let's zoom the console a bit. This will continue to execute. Now we can say number. Now we can say hello. Now we can say how long is this going to go on. And then we can say end. And now once we've printed end, what did we get? We got an index out of bounds exception. Okay, so something was wrong here. What was wrong in our code? Well, we can use the stack trace we just got. We can click it, and that would navigate us to the line that failed. Now, what you should have noticed by this point is the for loop I just wrote doesn't reduce its value, it increases its value. And since our check is if I is larger than 0, larger or equals to 0, well, what would happen here on the second iteration of the loop, on the first iteration, I would be words.length -1. That's okay, and we'd print the word. Okay, but after that, and you see that the string we got here, how long is this going to go on, which is the last string in the input, besides end. Okay, but on the next iteration, what happened? Well, I became words.length, because previously it was words.length -1, okay, and this generated an index out of bounds exception. And we're going to fix that by doing what we initially wanted to do, which was start from the end and reduce the index until we reach 0. So that was our issue, and this is how we found it. We used the stack trace to see where the problem occurred, and we will now start the code again and execute the same input. Friend, number, how long is this going to go on? And end. And what happened now? Oh, we got, yes, this is what we should have gotten. How long is this going to go on? Then we got number, then we got friend. These are the inputs which we added. You can ignore this error up to this point. This is a problem in my environment settings. It isn't related to the execution of our program. It is related to the after the execution of the program. So it's not an error caused by our code. This is the output which we wanted to see. By the way, if I start it in run mode instead of debug mode, it won't give us this error. Okay, so we learned how we can add an item to an array. Is this what we wanted? Well, no. We want to learn about lists. But why did I show you this example? I showed it because I wanted to illustrate how non-optimal adding items to arrays is. Notice what would happen on each execution of this for loop. We would read a line, and then we would increase the size of the array by 1, meaning we would copy all of the elements which we currently have and write them to a new part of memory, and then use that memory as our words array. And then we'd repeat it again and again and again, meaning that how many items we add, each time we have that many items being copied, or that many items -1 being copied. Each time we have to execute n operations where n is the size of our array currently. So this is pretty slow, since each time we spin up a for loop to copy items. On each adding of an item, we need to copy all other items instead of just adding a single item. Okay, so to save us from this problem and to save us from writing code this way, what we can use are lists. Now, lists are a concept from data structures, which are a subset of computer science. And a list in Java is initialized in the following way. It's pretty much the same as what we have for arrays, with the exception that you don't begin with the type. You just say list, which is the data structure, and then in these less than and greater than brackets, and we will begin calling them brackets even though they're mathematical signs. In programming, these are called template brackets or generic brackets. So inside these brackets, we will say what things we want our list to contain. The same way when we create an array, we say what type the elements of this array need to be. Well, here we just mark the type of the elements inside the list. And we initialize it with this phrase. We say new, the same way we say for an array initialization. And we say array list. Now don't worry about this, it will become clear in a few moments what this means, why this is array list and the variable is a list. I will explain this in this part of the lecture, but let's see how we initialize them first, and then we will explain what each part of this means. Okay, so we initialize a list of names. In my example it was words, by saying new array list, these brackets again, although we can keep them empty, or you can write string here, it's okay if you do, but it's not necessary since we've already told Java that our list contains strings. Okay, so what can we do with this list? Well, let's see it in code. We have an example in the PowerPoint slides, but we can use the code as well. So instead of creating an array of words like we have here, we would create a list of strings. So this list of string, list of string, the data type is string, and we will place that data type inside the list. Okay, so how would we create them? You remember what you saw on the slide, a new array list. We are creating a new array list. And now instead of doing this complicated add item routine, we can just say words.add and add whatever we want to add to this list. For example, this will be line in our case. So words.add line does pretty much what we did in this add item method. However, it does it faster, it does it with somewhat different code, but the effect is the same. Words will have an item added to its end. Notice that I haven't given any size here. So this words list doesn't care what size it needs to be. It determines its size by the number of elements you add to it. So you don't need to provide the size before initializing the list. That's the whole point of the list actually. It's a data structure that allows you to add items optimally to its end without needing to know how many items there will be in the input. Okay, so continuing on from here, how would we print these items? We've already added them to this list, and we have a for loop here that tries to print these items. But as you see, the list doesn't have a length, and it can't do this operation. However, it actually can, but the syntax is a bit different. So lists are the same thing as arrays. Lists internally are represented by arrays. They're not something magical that you can't implement on your own, and we will study how we can do stuff like that. But for now, we just need to learn the syntax of these lists and how we can use them the same way as arrays. So everything you've seen in arrays, you can do to lists. You can get the length of a list. However, the method you need to call is size instead of length, and it's a method. You call it, you place brackets after it. Okay? And everything else remains the same on this line. The for loop is the same as you would have a for loop in a normal array. Okay, and how do you get items from it? Well, you don't use these brackets, you use .get. And again, you have to provide an index, the same way as you would for arrays. Okay, so this is all these are all the changes we need to do to our program, and it already does whatever it could do with words, with arrays, but it does it more optimally, and it does it with less code. We aren't using this method here right now. We don't need it. Okay, so let's start the code again, so you can see that the execution is the same. And I can input friend like I had before, I can input number, and I can input something shorter than how long is this going to go on, lists, and then I'll input end. Okay, here is my output, the same output which we had previously, the same output as an idea. Of course, this value is different. Okay, so the same output, but using a data structure which provides an automatic add operation. So what we have to know by this point is that lists are initialized in this way. You mention the data type you want to store in the list in this type of brackets after the list name, and meaning after writing the name of the list class, which is list. So you say list, then you open brackets, you choose a data type you want to put in that list, in this case it's strings. Okay, you write an identifier for the variable, the same way you would do for an array, and then you say new array list, and these brackets and these brackets after that. Now this syntax may be a bit weird, and I'll explain the differences between array list and just list in a few moments, but this is the initialization. And from then on you use it as a normal variable, the same way you would use a string variable, the same way you would use an integer variable, and so on. You can assign values to it, you can get values from it, and you have the list functionality, which is adding items. You have the size of the list, which is words.size, and you have a getter, which returns the value of an index, i.e. it returns the element at that index. Okay, so let's see what other functionality the list has for us. So we already saw the add method. This allows us to add items to our list. And there are also functions like remove. So we can tell a list to remove an element, meaning that if we've added these 3 items and then say remove from this string, well, this string will not be present in the list after the execution of this method. So this removes an element and reduces the size of the list. Another thing we couldn't do with arrays. Okay, and we can iterate a list the same way we can iterate an array with the for each loop, i.e. the same way we did a for loop, we can also do a for each loop. So we can say words out and enter iterate, and this would create an iteration of the words. Only this will be sequential access to the elements, whereas our for loop here is in reverse, but the concept is the same. Okay, so you can iterate words, you can iterate lists the same way you can iterate arrays. Okay, so continuing on from here, what else can we do with lists? We can use integers in lists, or doubles, or chars, or booleans, and so on. Now, before we study this code, let's give some attention to the concept of using integers in lists. So when we want strings in lists, nothing special happens. We just use the name string. If we want integers, however, we don't say int like we do when we create variables. There are reasons for this, but Java basically doesn't support these so-called primitive types, int, double, char, float, byte, and so on. It doesn't support them as this type of parameter which appears between these angled brackets, between these template parameters. It doesn't accept them as template parameters. Okay, so how would we use them? Can't we create a list of numbers? Well, we can, but we need to use the full type name, i.e. we need to write integer with a capital I. The same goes for double, i.e. you wouldn't write double like this, you would write it with a capital D. And so on. Any type you want, which is a primitive type, you need to write the corresponding full type name, the class name of that primitive type. So for char or char, this would be character. Now, this is how you create them. How do you add items to them? Well, the same way you add items to a list of strings. Whatever the data type is, the lists behave the same way. They don't care what you place in them, the same way that arrays don't care what you place in them. Okay, so let's call this numbers, and if we want to add numbers to this list, we'd say just numbers.add of the number you want to add, for example 42, or numbers.add 13, and so on. And the logic remains the same. You can iterate them the same way, you can get the size the same way, and so on and so on. Okay, now what do we have here? We have initialization of an array list with syntax similar to how we can initialize an array. And before we actually see this syntax, let's talk about how we can create an array, i.e. create an array from some fixed set of elements and convert it into a list. Okay, so what can we do? Well, we can create an int array numbers array, and we can say that this array is a new int array containing the elements 1, 2, and 3. And we can do a for loop. We can then create the numbers list, and we can create a for loop which iterates the numbers array, and for each number in the numbers array we can add it to the numbers list, add number. So this is how you copy elements from an array into a list. Okay, so that's one way. Let's say we have our string array like we did before. So we have a string array words array, and it contains the words hello and goodbye. Okay, and let's say we want to set these values to the list directly. So this list of it will be strings, list of strings words equals new array list. But let's say we don't want to use this for loop. We want to do this directly. Now you can do that for strings. You just say this array, this is an array, and this is a list. So to convert this array into a list, you say you pass it as a parameter to the array list as an arrays.asList of words array. So what we say here is create a list from the words array. And this creates a list, and this list gets copied. This new array list function creates a new portion of memory, and this portion of memory gets assigned with the values from the words array. This is the syntax you need to use. You can't just pass in a words array because array list can't process arrays, but it can process other lists. So basically what we're doing here is copying a list, which is the words array converted to a list, copying that list into a new part of memory, which will equate to our words. So our words will contain a copy of the words array in a part of memory. Okay, so can we iterate them? Of course we can do words.iterate and print them the same way we did before. So this is just part of the initialization. Now you could do this thing. You could ignore the new array list part. And this would work the same way. We could still iterate the words and we can still print them. However, if you decide to add elements and you've initialized words with an array list, with a list that covers an array, if you use a converted array as a list, adding items won't work. Why won't it work? Let's say this is word. Why won't it work? Well, because this is still an array. It acts like a list. That's why we say arrays.asList. It makes it act like a list, but it isn't really a list in the sense that it can't add items, it can't remove items. It can access items, it can get values and set values of items, but it can't change its size the same way an array can't change its size. So that's why we write new array list around this arrays.asList, so we can get a copy which is an actual array list, and that array list can add items and can remove items. You can test this at home or wherever you're programming to see what happens in the different variations of this initialization. Okay, so this is how you convert an array to a list. Now, what you can also do is instead of creating the array, you can just say arrays.asList and list the items of that array here. So you can say hello and goodbye and remove this array. This has the exact same effect on words which it would have had if we had the words array and converted that. So arrays.asList works if you just pass it a sequence of parameters, and it also works if you create an array and pass it that array. This is pretty much equivalent for our purposes. Okay, so this is what we have in the PowerPoint slide. Okay, so removing elements always accepts an index. So if you want to remove an element from a list, you say words.remove, and you can say which index you want to be removed. In addition to indices, so the default position is removing indices. So in this case, if we now print the list, if we say words.iterate, what we have here is just the goodbye string. So system.out.println of word. Let's print the word. What would we have on the console? We'd see just goodbye. Why? Because we removed index 0 from the list. Here we have only goodbye, even though we've added hello and goodbye. Why? Well, because hello is the index 0 and goodbye is index 1. So when we say remove index 0, index 1 becomes index 0 and index 0 is no longer there. And the size of the list is now 1, not 2, like it was before. Okay, you can also say words.remove and pass in a parameter which equals a value in the list. So you can say remove goodbye instead of removing 0. Now this would search in the list and find where goodbye is located and remove that index. So now when I start the code, you would see only hello printed on the console. Here we go. Okay, so we've got that covered. And if you have, now what happens if we have a list of integers instead of a list of strings? Well, let's say this is a list of integers and these are Shift and F6 allows us to rename. These are numbers, and let's say these numbers are 1, 2, and 3. Okay, so now when we say remove 1, what does that mean? Does that mean remove the index or remove the number? Let's just complete the code. Int number, in numbers, print line, this number. Okay, so what does remove mean when you provided an integer parameter and your list contains integers? How does Java know if it's supposed to remove that index or that value? Well, Java defaults to the index. That's why in the beginning of the remove description I said you always supply an index. So the default behavior, if you supply an integer, is for that to be an index. Now if you want to remove the element, what you need to say is numbers.remove integer.value of, and here you place 1. Now the reason for this is a different signature than the signature of remove with just an integer, because integer.value of returns an integer object, and when the list of integer objects sees remove by an integer object, it knows that that means remove the element that has that value, not remove that index. So the signature of remove, there are two signatures of remove. One signature of remove is the type you've written okay, so first signature of remove is just int index. So this removes by index. The other signature of remove, we've talked about signatures before. The other signature of remove is, in this case, it would be integer element or value, or let's say value, that would be a bit more clear. So this is the other signature of remove. So this removes by value, and notice what we're doing here. We're saying integer.value of 1. This will create an integer object, meaning that when that integer object is passed to remove, the version of remove which will be called is the version that accepts a value, not an index. Okay, so I hope that's clear. If not, just remember that if you want to remove a value, you need to say value of the value. If you're using integers, anything else you can just remove the value by providing the value. And if you just provide an integer, that's always the index which you want to remove. So what will this remove? Well, this will remove index 1. So this is index 1 here. It will remove the value 2. Whereas remove integer.value of 1 will remove index 0, because value of 1 means this element, the element that has a value of 1. And Java will go find where this element is located and remove that. Okay, and this removes the first occurrence of this element. So if this element appears again, you would have to remove it again if you want all of the items to be removed. How you do that? Well, here's a hint. Remove returns a Boolean value, which says whether remove found something to remove. So how would you remove all items of this value? Well, pretty simple. You see if remove found something, and if it did, then there could be something more which needs to be removed. If remove didn't find anything, well, you don't need to continue on. But if it did, you have to run the remove again. And then guess what? You do it again and again and again until found becomes false. So what's that? That's a while loop. So pretty much while numbers dot remove this value, execute. You can decipher what this code does at home, but I just explained it before writing it, so you should be able to do it on your own. Okay, so this is the remove function. We have the add function, which we already saw. You also have a function which is add that accepts an index. This just inserts the item at that index instead of inserting it at the end. So basically what you'd have happen, and we have examples here which I'll show you in a while. If you say add at index 0 minus 100, minus 100 will become the first element in the list. Okay, and it will push all other items to the right. So if you have the list 1, 2, and 3, and let's say this list is named just list, and you say list.add at index 0 minus 100, what would happen is that 1, 2, 3 would become minus 100, 1, 2, 3. So add just pushes everything to the right. This index, it pushes it to the right, you know, this was index 0, now it's index 1. And in its place, it places the number which you provide here. Okay, so this is how you use the add function if you want to insert at a certain position. This is how you use the remove function if you want to remove an element, and this is how you use the remove function if you want to remove a value. You use value of. Okay, so lists are pretty much data structures from computer science. A list has this functionality which we already saw. It also has the contains method, which answers the question, is an element contained in the list by its value? So if you have hello and goodbye, if in a list, if you say list.contains goodbye, it will return true. Okay? And we also have set. This is the only method which we haven't seen yet. This just changes the value of an index. This is the equivalent of setting an element in an array. So if you have an int array numbers array, which is a new int array of 1, 2, and 3, just like we have on the line before that. If you say numbers array position 0 set value 42, this is the same as saying numbers, the list, dot set at position 0 the value 42. This is what set does. It changes the value, and it is the absolute equivalent of accessing an element by index in an array and setting its value through the equals sign. Okay, so that's what a list supports. These are the primary operations of a list. And there are different variations of lists. What we're studying now is the array list. This is the type that can automatically and optimally add elements to its end. Now, array list is a type of list, so you can have list, which is your variable, but this list can be an array list. It can also be a linked list, and a lot of other options in Java. So what we write to the right of the equals operator, the assignment operator, what we write here after the new keyword is the type of list we want. Whereas we just say this is a list for the variable and use the type of list we want when initializing it. You can play around with the other list types, although we won't be needing them yet for this lesson. Okay, so this is the difference between array list and just list. Array list is a specific type of list, whereas just saying list means that you want something here in this variable that is guaranteed to have this functionality. Anything else the array list adds, you don't care about that if you just say list here. By the way, you can also say array list here, but in general terms, it's better to use the more abstract version of the type you're creating. So for array list, linked list, and so on, you would mostly use list, unless you have some specific reason for accessing additional functionality that array list provides. But we won't be using that for this lesson, so we will study it further on. Okay, so this is the data structure, and here we have some examples of how it works. So adding an element just increases the size of the list, the dot size of this list of integers, and appends always to the end. If you just say add, it adds to the end of the list. Okay, what does remove do? Well, it searches for an element. If you say remove value of 10, it will search for this element, find it here, and then pop it out of the list, which would reduce its size. And all items to the right of the list, or upward from, not from the list, from the position which you removed, will be shifted to that position. So elements to the right will be shifted left. Okay? And if you're adding at a certain index, in this case, if we're doing add at position 1 the value -5, like we'd be doing in this animation, what would happen is -5 would go here. Why would it go here? Well, because this is index 0, this is index 1, and adding pushes all indexes to the right or upwards. So this will go here, push the element 2 to index 2, and we'll insert -5 in this position. So let's see it in action. It pushes it up and inserts the -5. And again, the size increases. Okay, so we've covered the basics of lists. From here on out, we just have to cover how we can read them from the console, write them to the console, and that will be pretty much similar to what we're doing with arrays. So let's have a break and we'll continue with reading and writing afterwards. And now we're going to talk about how we can read lists from the console and how we can write them to the console. Now, we already actually did parts of this, but let's do it in a more consistent manner and study the various ways in which we can do these operations. Okay, so one option you would have when reading lists from the console is doing it the same way you do it with arrays. So if we have an int array called numbers, what we do for this int array is we'd usually read a number of elements, let's call it n, and say this number n, first we'd need a scanner, of course, a new scanner that reads from system.in. Okay, so this scanner is a new scanner that reads from system.in. And we'd say the number of elements is equal to scanner.giveMe the next integer in the input. Okay? And then we'd initialize an array which contains that many elements, a new int array which contains n elements. And then we do a for loop starting from I equals 0, continuing to I less than n. And we'd read each item of the int array. So we'd say numbers at position I receive the value of what? Scanner dot give me the next integer from the input. Okay, so this is how we read an array, and this should hopefully be clear up until this point of the course. So, what do we do if we have a list? Well, something similar. We wouldn't create a numbers array. We'd create a list out of, you remember that we need to use the capital I integer class here instead of just int, numbers, which is a new array list. And that's pretty much it for the initialization. We continue n times in this for loop, and we do numbers.add scanner give me the next integer. Notice that we don't care about the index here because add automatically adds at the last index. So this gives us the same result for the list that it would give us for the array. Okay, so what do we do from here on out? Well, one optimization which we can do is, since we already know the size, we can provide a hint here in the array list constructor. This initializes an array list. We can provide a hint of how many elements there are going to be in our list. Now, this doesn't limit the list to that number of elements. It doesn't mean that we can't resize it further on. It doesn't even have to be anything. It can be 0 here, no problem. The list will resize itself. But if you add a number here which is close to the number of elements that you actually have, this adding of numbers in the integer list will be a bit faster. Not by much, but it's still an optimization which, if you can do it, why not do it? But it isn't necessary at all. So this is one way of reading a list of numbers from the console. It's the same thing as you would do with an array, so we won't talk about that anymore. So the interesting stuff is when you want to read a list from a single line, so you have an input like so. You want this input to be added inside the list. How would you do that? Well, we've done that for arrays already, so let's do it for lists. Shouldn't be that hard. Lists seem a bit easier to use than arrays, aren't they? Because you can always add elements into them. Okay, so how do we do that? Well, we just say we have a numbers list. Let's not read the number of items because we won't have them in the input. We will have something of this sort. And I'll even copy it so I can reuse it, and I'll place it in a comment in the code so I can easily copy it around. Okay, so I have a scanner here that's going to do the reading for me, and I have a numbers list. Now, what I do know about this line is exactly that it's a line. It ends with the new line symbol. Well, what functionality can we use in Java to read an entire line? Well, the scanner.nextLine, or the scanner.nextLine function reads, the scanner.nextLine method is the more appropriate term, reads until it reaches a new line symbol. So when we reach this end of the line, we will have a string which contains all of the symbols from this line. So let's have the line here. Okay, so now we have a line of numbers. How do we convert them into a list of integers at that? Well, what we do is we want to convert this line into pieces that are separated by spaces. We've already done this for arrays. What does it look like? Well, it's line.split, and here you provide what you want to split by. This regular expression here which we provide can be just a simple space by which we split, or it can be a more complex description of how we want to separate the items in this line. But for now, we will just use the split by spaces because that's what we want. So what does split create? Well, if I don't know, I can just say split line. This is the split line, a line that is split into parts. And I can say out and enter. And this will allow me to create a local variable, and IntelliJ will automatically describe what the data type of this variable is. Okay, so it's a string array. How do we convert a string array to an integer list? Well, I already showed you how you can copy items from an array to a list. You just use a for loop. So you say split line, iterate, alt and enter after split line, we'll iterate them. And this will iterate each item in this split line. Okay, so what do we do to add it to the list of numbers? Well, I just need to say numbers.add item. However, item isn't a number, it's a string. But it's a string that represents a number. So I'd have, for example, quotes 2, or quotes 30, or quotes 40, and so on. Okay, how do we convert such a thing into a number? Well, I just use the integer.parseInt method in the integer class. Okay, so this will convert our string 2 or our string 30 or our string 8 and so on into an integer number, and that integer number I add to numbers. and then I can do something with numbers. For example, I can print them to the console. So I can say numbers, alt and enter iterate, and for each number in numbers, just system.out.println this number. Now notice, by the way, that IntelliJ generated the full class name. Let's say the full class name isn't the exact term we should be using here, but for the purposes of this lecture, when I say full class name for primitive types, I mean these capital case, capital first letter, full word descriptions of the types. Once we've talked about classes and objects, full class name will mean something different. Okay, so this integer number, we can convert it to an int. This conversion happens automatically in Java, so wherever you're getting an integer, you can change it to an int. And if you have an integer somewhere, you can provide an int there, and Java automatically converts them. The only restriction is inside these brackets, you need the capital case thing. Okay, so this is our printing and this is our reading. Let's see if it works. We can start the code here and see what it does. We'll wait a bit, and now I'll copy this input which I got from the slide and I'll paste it into the console. Now when I hit enter, we will do the split operation. First off, the scanner.nextLine operation will finish because it has reached a new line symbol. It will generate the line string, and then this line string will be split by spaces, i.e. we will get a split line array which contains the string 2, the string 8, the string 30, the string 25, the string 40, and so on. And then for each item in this split line, we get the item, parse it into an integer, and add that to the numbers list. Okay, and then we print that. Now, instead of writing this whole thing every time you need to parse a string into a multiple of integers, what we can do is extract a method over here. So I can mark this code and I say Alt and R, refactor, then X extract, then method. I want a method. And now it says, okay, I will create the numbers parameter and the line parameter. I don't need the numbers parameter. The reason it creates it is because I've created the numbers list over here and it doesn't have it in the code I just marked. But I actually want the numbers object initialized inside the method so that the method will then return that numbers list. So I'd mark this, Alt R X M, and say parse numbers. Parse numbers from a string line of numbers. The same way we have integer.parseInt from a string. Well, I have parse numbers accepting a string, and it will return a list of integers. That's not completely visible here, but if you open this drop down here, you would see that it would be a list of integers. And actually you can see the definition of the method over here. Okay, so let's create this thing, and now we have a function that simply parses a number from a line of strings, from a string line. And now we can inline this line string, so we don't have a special variable for it since we're using its value directly. Okay, so we broke down that code into just parse numbers accepting the next line from the scanner. And now you have code that reads integers from a string on one line. You don't need to write the loops again and again, you just need this code copied somewhere inside your program. Okay, so that's one way to read a line of integers from the input using only one line of code. It's not exactly one line of code, but from the point of view of the main method, it is a single line of code. Okay, so what did we have in the slides? We have another option for parsing items from a single line, and that is using the Stream API in Java, the Stream API, if you want to Google that. We haven't studied it officially, but we're showing you bits and pieces of it because it will be useful for later on. So the Stream API allows us to convert this splitting of the line into a stream, and on streams you can do some special multiple operations using single invocations of methods. So what we're saying here is convert this line into a stream and collect it as a list. So convert this array of strings into a list. Okay, and then we're saying iterate each element of the string list and add it as an integer to our numbers. It's pretty much the same code which we had in my example I showed you, but you can make it even shorter than that. You can say arrays.stream like before, and then before collect it as a list of strings, we can say map it. How do you map it? Well, by using integer parseInt. So this line here, this part of code here, does the for loop which we wrote manually. So if you want to do it in a shorter way, what you're saying here is for each map means for each item in the stream, for each string in this split of strings, for each item in the string, convert it to an integer. How? Well, using the integer parseInt method. So it's basically calling this code. For each item, get that item and parse it into an integer. And then we're saying collect those integers which you got by mapping into a list. Now, if you don't understand this completely, and if it's not intuitive to you, my suggestion is just use the methods which we implemented. Implement your own methods. This thing here is just a complex description of a method, and we will learn to use such code and write such code ourselves even, but that would be further on. So the reason we're showing you these things right now is because that's one additional way of reading strings, reading numbers from a line of strings, and it would speed up your coding process. But it doesn't mean that you always have to use this approach. It's completely fine to use the for loop which we implemented ourselves. And actually, confession time here, most of the time I use my own methods for parsing such types of data instead of using the built-in stream API. I use the stream API only if I have some complex sequence of operations I need to execute on large amounts of data. It's completely fine using a parse line of numbers method like the one we implemented. Okay, so how do we print on the console? Well, the same way we do it for arrays, and actually I showed you one way of printing to the console, which is using for each loop. Another way would be using a normal for loop. So I'd say for I, enter, start I from 0, continue until I reaches numbers dot size. Again, this is dot size, not dot length. Dot length is for arrays, dot size is for lists. Okay, until we reach dot size, and system.out.print. Let's do it with printf so we can print the index, and we can say the value here is at index D. What are we doing here? We're saying print digits at this position, then print at index, and then print digits again. What digits? Well, the first set of digits will be the number from the numbers list, meaning the element at position, which position? Position I. Okay? And we're saying that the number at position I is at position I. So what will this print? It will print something of the sort 13 at index 0. Then it will print 20 or 42 at index 1, and so on and so forth. That's another way to print a list. Okay, so let's see that actually. Let's input some numbers and see them printed. Now, what am I missing here? I'm missing the new line. How do I write a new line in a printf statement? %n. That means use the new line symbol for the current operating system and place that at the end of the line. So I'll stop this code again, I'll start it again, and I'll input some numbers. For example, 13, 42, 4,213. Why not? Okay, let's print them. Okay, so what happened? We got 13 and 42 on separate lines and then 4,213. Why? Well, because I have a for loop printing that data previously on the previous part of the code. So if I remove this first printing will not be here. Okay, so here's the next printing: 13 at index 0, 42 at index 1, 4213 at index 2. So this is how we print lists onto the console. Same thing as we do for arrays. Okay, so let's continue on. What else can we do with printing? We can use string.join. Now, if you have a list of strings instead of a list of numbers, the same way you can do string.join for an array of strings, you can do it for a list of strings. So if we have a list of strings, a list of string words like we had before, and this list of strings is initialized by a new array list, and let's place values directly here. How did we do that? We used the arrays as list and list the values here. So let's place the values, hello and goodbye. Okay? No, changed to Bulgarian, sorry about that. So we're using the list of strings, a list of string words, which contains hello and goodbye, and we want to join them into a single string, which we can print on the console. How do we do that? We just use string.join, pass in the words, pass in the separator we want to use, for example, a comma and a space, and this will create a string, which is our list of words joined together. And let's call that joined. So now we have a list of strings, a string which has these strings joined with the separator comma, and if we just want a separator space, well, we'd say a separator space here. Okay, so how do we print this to the console? The same way we print any normal string. We just use system.out.print or println or printf or whatever we wish to happen. Okay, so this would print hello, comma, space, goodbye. Oh, it didn't print that. Why didn't it print comma space? Because I removed the comma from here. Let's place the comma again, start it again, and we will see the comma space separation and printing. Here's it. Okay, so we have hello, comma space, goodbye. So this is how we would print a list of strings if we wanted a shorthand instead of using the for loop. And again, if you're not using strings, you'd have to do the for loop. So in that case, I'd advise you, well, implement a method which prints a list of things, for example, integers, on the console. And you can even include a parameter which is a separator by which those items should be printed. Okay, so this is how you print to the console, pretty much the same thing you would do for arrays. So from here on out, we have some tasks we need to implement, and the first of those is how can we sum a sequence of numbers into a list which contains no equal numbers side by side. So what do we have here? We have 3 and then 3 and then 6 and then 1. And the task is keep summing the items until there are no two items which have equal value next to each other. So we have 3 and 3 here, they have equal values, so these 3 and 3 need to become 6. But then we're having 6 and 6 next to each other, so we'd sum these 6 and 6 together and receive 12, remove these from the list, and when we reach the point when we have 12 and 1 in the list, there's nothing else we can do, so we print the list. That's our task. And here's another example. We have 8, 2, 2, 4, 8, 16. What would happen here? Well, here's a pair of equal values which are next to each other. So what happens here? Well, this 2 gets summed up in this 2, so this 2 becomes 4. This 2 gets removed from the list. But now we have 4 and 4 next to each other, so we repeat the same operation. So we sum 4 and 4 and we receive 8 here at this position and remove this 4 which was at the next position. Okay, but now we have, what do we have? We have 8 and 8 and 8 again and 16. Now there's an additional thing we have to keep in mind here is that we should do this summing from left to right. So in this case where we're getting left with, let's edit it directly. In this case in which we're getting left with 3 equal values, we should sum the leftmost 2 values. So from left to right, when we see 8 and 8, we need to convert it to 16, and now we have 16, 8, 16. There are no values that are next to each other now that are equal, and we print the list. And same thing for the example over here. Okay, so how do we do that? Well, we'll be removing elements. We will also be calculating sums and changing values. So since we'll be changing values and we will be printing some subset of those values, we probably need some sort of collection, an array or list or something which can contain many elements. Okay, well, would it be an array? Well, it won't be an array because we need to remove elements. It could be an array, but it would make our lives quite harder if we're trying to remove elements using arrays. So we will just use a list. Lists have built-in functionality which allows us to remove elements. Okay, so let's do that. Let's write the code which will execute these instructions. What do we need? First off, we need a list of numbers read from the console. Hey, guess what? I have a function that does that, a method that does that. Okay, so here's the scanner. How do we use it? Well, I'll just say parse numbers, and parse what numbers? Well, the numbers that are on the next line of the scanner. Okay, let's get a result from this. This result will be a list of integer numbers, and this list of integer numbers, by the way, this task could be decimal numbers or any other type of data type. We don't really care about the type here. We care about the logic of removing items and setting items. I'll leave the details of data types to you to try out at home. So, a list of integer numbers, which is the numbers we've read from the console. Okay, so this code here does all the reading we need. From here on out, we just have calculation and we have printing to the output. And actually, let's print to the output. Let's do a for loop. Let's write numbers, press Alt, and then press Enter, and ask IntelliJ to generate for each loop for our numbers. I'll convert this to a simple int because I prefer simple ints when I can use simple ints. And say system.out.print this number with a space after it. Now, these are again details which may need tweaking. If the task doesn't require a space after the last number, well, then I need to do some modifications here. But again, those I'll leave up to you. We've done stuff like that already. So, how do we handle this task? This part of the code should do the summing. Now, what you'll see in the slides from here on out will be a for loop that traverses these numbers and does the sums. My suggestion is we don't use a for loop. What we will use is a while loop. Why will we use a while loop? Well, because I would have to be moving forward and backward when doing this iteration. So a for loop typically just steps on items in a sequence. That's fine, but once you've had a change in this sequence, you might need to rerun the for loop on it, and then rerun it again and rerun it again. That would require you to reset the index of the for loop. I personally prefer my for loops to be always sequential, and in cases where I have to move the index forward and backward, I use while loops. Okay, so what do I mean by this? Well, to sum these numbers correctly, what I'd need to do is start from index 0. So I'll create an integer, index 0, and then I'll say while index is less than numbers.size, and this might need editing, but let's just implement the code that iterates, and then I'll think about how I can change it to fit my specific task. Okay, so let's just iterate these numbers. Let's say index plus plus. So this iterates the numbers in the numbers list. Okay, how can I use this to my advantage and do the sums I need to do for my task? Well, the check is pretty simple. If I'm at index 0, do I need to do something? Well, I need to do something if index 1 contains an item that is equal to the index which I'm at the current point. So I have index 0 and I'm checking for equality with index 1, with the element at index 1. So I have the current index and I have the next index. So the next index is index plus 1. Okay, so when do I need to do something? When the item at index is the same as the item at next index. So I need to do if numbers dot get of the current index equals numbers dot get the next index. So if these two are equal, I need to sum them, correct? So I need to do get this index again and sum it with the next index. So this is the sum. Okay, so you're seeing a repetition of code. If you're seeing a repetition of code, you should be thinking about how can I make this code not repeat. So what I do is Control-Alt-V, can extract a variable, and I'd want all occurrences of this string to be replaced. And I'd say this is the current item. And the other thing is the next item. And again, I'd convert them to simple integers when I know I can convert them to simple integers. By the way, if you're seeing integer with capital I, this means that this integer could also, except the values for an integer, it could also contain no, the value no, which we've seen for strings, and which we've seen for arrays actually, and for lists, and for any other type of object, but we will discuss objects later on. So, to simplify for now, if you see a capital case integer, you can, in most cases, convert it to a simple integer. So, the current item and the next item, if they are equal, we need to find their sum. What else do we need to do? Well, we need to get that sum and change the current item, which is index 0, change it to the sum. In this case, 3 plus 3 equals 6, so this index 0 will become 6. Okay, let's do that. We need to numbers dot change the value set at which index? Well, the current index. No, the index, we've called it index. The current index is index. And what value do we need to set on this index? Well, we need to set the sum. Okay, so now what we did is change this tree. Change this tree to a 6. What else do we need to do? Well, the other tree over here needs to be changed, needs to be removed actually. We don't want it. It already participates in the sum, so we don't want it in our list. We want to remove it. This way, we change the current value, we remove the next value, and that's as if we've merged these two values together into a single value using their sum. Okay, so I need to numbers.remove which index? Well, the next index on which next item is located. Okay, so this removes the other value of 3 over here. Now from here on out, what do I do? Well, I've removed the index, and what now? I've done the sum, made these two values. I'm still at index equals 0. So I'm still here. However, index 0 is now 6, and index 1, since I've removed 3, becomes what? It becomes 6 again, right? So any values after the index I've removed are shifted into its position. So 6 becomes index 0, index 1, and 1 goes to index 2. So typically I would need to iterate forward to iterate the entire list. However, since each deletion moves all the items from the right of that deleted position, moves them to the left, that means that at this position which I just deleted, I now have a new value. Since I have a new value, and that value could be another equality with my current item, I don't want to move forward, because if I move forward, if I say I if I say I equals 1, what would happen after I've done the sum? Well, I'd come here at index 1, but at index 1 we now have 6, correct? Because I've moved, and at index 2 I have 1, because this has moved, and this is no longer the last item. There is no such item at the end of... The list size isn't that big as it once was. Okay, so now I'm at index 1, and I'd miss this sum of 6 plus 6, because I'm always looking from the current index to the next index. So I don't want to go to index 1 if I've done a deletion. I don't want to step on the index which I just deleted, because that index is now a different value. That index contains a different value. So in this situation, I don't want to increase my index. So I would only increase my index if nothing changes. So I continue on with iterating my list only if nothing changes. Only if, for example, in this situation, if I'm at position, maybe this situation isn't very good. Okay, let's use another example. Let's say we have 1, 2, 3, 4. When do I change the index? Well, I get to index 0, this is index 0, I compare it with index 1. There is no equality, so nothing happens. And then, if nothing has happened, if I haven't deleted items, I go to the next index. So I go to index 1. And then I check for equality again. I check for equality between index 1 and index 2. Again, no equality, so I go to index 2. And so on and so forth. So I only increase my index if nothing happened. However, if I find an equality, I keep my index the same, so that the deleted position, I can check it again for an equality with the current position. Because if I have 1, 1, 2, 3, 4, now this case is more interesting. Why? Well, because I'm at index 0, I'm here, I see an equality, these two are equal. In that case, I'm making their sum, I'm assigning position 0 to 2, I'm removing this item, and now position 1 becomes what? Well, position 1 becomes this number 2 over here, because all of the elements to the right of the one I deleted here are shifted to the left. So this is now the new index 1, and this is the new index 2, and this is the new index 3. So now I have to check again, because at index 1 I might have another equal item, and I do. I remain at index 0, and I check the 2 from index 0 with the 2 from index 1 again, and I see again another opportunity for creating a sum. And I do that sum, and I receive 4 here. 2 plus 2 is 4. And I remove this item. Okay, so what happened now? This index is no longer index 1. Index 1 becomes this thing over here, the number 3, and index 2 becomes the number 4. And now I check again. I'm still at index 0. I check at index 0. Is the 4 at index 0 equal to the 3 at index 1? Well, it isn't. And in that case, I move on. I change my index to the new index 1. I go over here. I do I++ or index++. Okay, so this is what we have in this situation. One thing I'm missing from my code currently is that I'm not doing a second loop around over the numbers. So in this situation, I'd go over here and I check, okay, no sum. I'd get over here, okay, here's the sum. So this becomes 4. And okay, here's the sum again, and this becomes 4. Okay, so here's the sum again here, and this becomes 16. Okay, and this thing also is a sum, so I'd get 8 and 32. But that's not what we want. We want each time we get a sum, we want to start from the beginning. Why? Well, because we need to do the sums from left to right. Whereas my code always does the sums from where it is located. So it can miss if there's an equality between the current element and the previous element. So what I want to do is just when I do a change here, I want my index to become 0. I want to start over. The moment I see a change, I start over from the beginning of the list, as if that's what my initial input was. Because this task is just each iteration, each change just generates a new list, as in the input, which we need to make sums for. Okay, so this code over here will do what we are expecting it to do. It will sum the items, sum any two equal items which appear in the list next to each other, and it will print the output. Okay, let's see. Testing with this example. Oh, I got an error. Surprise, surprise. Remember when I said that I need to tweak something on the while loop? What do I need to tweak? Well, I'm saying continue until index is less than numbers.size, meaning that the last value of index would be, for this case, the last value of index would be 0, 1, 2, 3. For 4 items, it would be 3. However, I'm trying to access, each time I'm trying to access the next index. Next index is index plus 1. So for this case, when I reach index 3, I would try to access index 4, but there's no such thing as index 4, and because there's no such thing as index 4, I get an error. Okay, so where do I need to continue to? Do we need to reach the last item? Do we need to reach index 3? Well, no, we don't, because there's no sum to be had here. Since we're always making the sum from the current item and the next item, we just need to reach the second to last item. So we need to reach index 2, so we can check with 1, but we don't need to reach 1 and check with whatever's after 1, because there's nothing after 1. Okay, so we don't need to continue to numbers.size, we need to continue to numbers.size minus 1. So we need to continue to less than numbers.size minus 1, meaning that numbers.size here is 4, the last index is 3, so 4 minus 1 is 3, and we want to be less than 3. Less than 3, we have the indexes 0, 1, and 2. Okay, so that's our issue with this code. Let's start it again. We did some pretty quick debugging, but I think you got the gist of it. Let's enter our input again. 3, 3, 6, and 1. 12 and 1 is my output, exactly as it was in the slides. Now ignore again this error. If you see this JDWP error here, you can ignore it for now. This is setting in my environment. It's not related to the task we're solving. Okay, let's use this example and see what it prints out. 16, 8, and 16. That's what we wanted, and we can test this example and so on. I won't test the last one. I'll leave it to you. I suggest that each task we solve here, you do at home. Even though you've seen the solution, it's good to have the practice of just having these things intuitively in your mind. The reason I found my error so quickly is because I've written code like this a lot of times. So writing code a lot of times saves you time when you need to be quick. It's like practicing any other activity. Okay, so we got the solution to this task, and here's another way to solve it. We can read it using a stream from a line of the input, map it. Again, I said the types I'm using in my solution aren't the correct ones. The actual task uses the double data type. So here we'd have mapping by the double parse double function, collecting into a list, and here we're using a for loop to iterate the items. We reach the item before index -1, size -1, for the reasons we just described, and we pretty much do the same thing. However, we need to set our current index to -1 instead of to 0 like we did in our for loop, because the for loop always does an I++ at the end of its execution. So if we set it to 0, the I++ will change it to 1. But we want to start from 0, so we set it to -1 and increase that -1 to 0 and start over. See why I suggest we use while loops in which we fully control the iteration? Okay, so again, this is part of the same task. The solution here is separated into separate methods. You can check this type of solution and implement that if you want, whichever you prefer. The reason I'm implementing a different solution to the one in the slides is so that you can have two viewpoints on solving this task. Most programming problems have multiple solutions which you can use to solve them. Okay, so here's a task for Gauss's trick. we will skip that one in favor of another task we have ahead of us. But in short, what do you need to do here? Well, you would have a list, and your task is to sum the first item and the last item, the second item and the second to last item, and so on, and do nothing with the middle item if there's such a thing as a middle item. So this would give you 663, and remove the items you've just summed. Well, this is pretty much a simple task. You need a for loop. You need it to start from index 0, and you need it to reach, in this case, index 2. What is index 2? Index 2 is the size divided by 2. So you have an I loop starting from 0 to I less than size divided by 2. For size 4, it's the same thing, right? So for size 4, you have 0, 1, and you don't want to reach this index, you don't want to reach index 2. So less than index 2 and less than index 2 in both cases. So even or odd number of items, it's the same thing. It's still a division by 2. Okay, so that's because of integer division losing accuracy when you have a remainder. Okay, so in both cases, you're going to size divided by 2. And what would you be doing? Well, you're calculating the sum of the sum of I plus the sum of size minus 1 minus I. Why is it size minus 1 minus I? Well, because if I is 0, we would get size minus 1 minus 0. So size minus 1. So index 0 will match index size minus 1, which is what we want. And index 1, we want to match size minus 1, i.e. size minus 2. And so on and so forth. And you just need to remove this index after that. And this is what we have here in the for loop. We're just setting the current number to the sum of the numbers I just mentioned, and then removing that last number. Okay, so from here on out, what I wanted to solve with you is the merging lists problem. So what we have here, and that will connect nicely to the next topic which we have to discuss. What we have here is two lists with randomly distributed sizes, meaning that they won't be of equal size, or they could be of equal size, but most test cases will not contain lists of equal size. And we want to merge position 0 and position 0 of the first and second list, then position 1 and position 1 of the second list, and so on. So what we want to do is, if we have 1, 2, 3, and 4, 5 here, what we want to do is get the list 1 from the first list, 4 from the second list, 2 from the first list, 5 from the second list, 3 from the first list, and that's it. If we had more numbers here, for example 42, 42 would come right after 3. So we take from the first, we take from the second, and then we repeat. We take from the first, we take from the second, and then we repeat. We take from the first, and oops, there's nothing here, there's no item in the second. So we would need a check. We would start and we would walk the entire list, the larger of the two lists, and while walking the larger of the two lists, we will just check which of the lists has an item. If the first list has an item, use it. If the second list has an item, use it. If not, don't use it. Okay, that's a simple for loop, and it might seem like a simple task, but I'll do a modification of this task so we can link it to the next subject, which is sorting. Okay, so what I'll be doing is reading two lists of numbers. Now, whenever I have two similar things which I need to read, like in this case numbers 1 and numbers 2, or list 1 and list 2, I like to use alphabeticals, so numbers A and numbers B. Why? Because A and B are a bit easier to distinguish from 1 and 2. That's a personal preference. It's not something you are obliged to use every time, but here's a view into how my mind works. If your mind works differently, fine by me. Whatever floats your boat. So let's do the thing we wanted to do. We want to read two lines of numbers. Okay, we read two lines. We read a single line, then parse it into numbers, and we read another line and parse it into numbers. Let's start a for loop now. How many iterations does this for loop need to have? Well, I'd say this for loop needs to have as many iterations as there will be maximally items in one of the two lists. So my idea is the following. Go through the two lists. I don't care which of them has the larger number of items, and try to pick from the first, from the second, from the first, from the second, from the first, from the second, and so on. Okay, so what do I do? Well, I do the following thing. I start a for loop, starting from 0, and continuing to math.maximum of numbers A and numbers B. So what so that wouldn't be numbers A and numbers B because those are lists, right? We want not the maximum of the lists, we want the maximum of their sizes. So we'd either continue to numbers A.size or to numbers B.size depending on which of these two has the larger number of items. Okay, so from here on out, what do? Well, we just start pulling items from the respective lists and placing them into a new list. I'd create a new list of integers, which I'd call merged equals new array list. I initialize it in this way, and before I construct the list, let's print it so I don't forget printing. Okay, so I do merged alt enter iterate. For each integer in merged, print it system.out.print align, or just print that integer, and add a space after it. Okay, so I have my printing, I just need to create my merged list. How do I do that? Well, I already told you. Since we're continuing to the maximum of the sizes of both lists, that means that if the lists are equal, let's assume the lists are equal, then we'll handle the case in which they aren't equal in size. Okay, so what do? We add to merged from numbers A, give me the index at position, the item at position I, and then from numbers B, get me the item at position I again. Okay, so that gives me the merged list. Now this is only if my two lists are of equal size. If they aren't of equal size, what would happen? Well, let's say numbers A is, 1, 2, 2, and 3, whereas numbers B is 4 and 5, like we had in the example before. I'd get 1 and 4, so my merged list would become 1, 4. Then it would become 2, 5. And then, since we're continuing to the maximum of their sizes, we would reach index 2. So this is index 2, since we're going to less than maximum of size of the first and size of the second, which is less than 3, because this is the larger list with size 3. Okay, so we're continuing to less than 3, and we'd get to 2, 5. We'd add the 3, we're on this line now. We'd add the 3 from the first list, but for the second list we'll get an error, because the second list has no such item as numbers b.get index 2. There's no index 2 in numbers b. Numbers b only has index 0 and index 1. Okay, so how do we fix this? Well, we only take an item from the list if it has such an item. So what our check is, if numbers a dot size is larger than I, then use from numbers a, because we could have the same situation in reverse. Okay, and again, if numbers b dot size is larger than I, then get from numbers b. Notice that this isn't an else if. This is two separate ifs for two separate lists. They don't have anything in common except that the fact that we're adding both of their items into the merged list. So we're checking, can I add from A? If I can, then I do. Can I add from B? If I can, then I do. And that's it. Okay, so let's test this with the input I just made up. 1, 2, 3 on the first line, 4 and 5 on the second line. 1, 2, 3, enter. 4 and 5, enter. Let's see what happened. 1, 4, 2, 5, 3. 1, 4, 2, 5, 3. That's exactly what I wanted to happen. Okay, and that's for different size lists. Okay, let's test with the input data that we have as an example here. let's start this code again. I'll just run it this time. Pasting this code, 162738845. Is that the input I wanted? The output I wanted? Yes, 162733845. 3845. Yes, it seems like the same output. Now, if I had more time, I'd give more examples. I'd test different cases. I'd test an empty list with another empty list. I should get an empty result. I'd test an empty list with a single item list. I'd test an empty list with a multiple item list, and so on and so forth. You have to test out different combinations of inputs, different conceptual combinations. You shouldn't test 1, 2, 3, and 4, 5, and then 1, 2, 3, and 6, 5. It's the same type of input in regards to our algorithm, but different sizes now have an effect on our algorithm. Okay, so before we go into the break and before we continue with sorting, let's talk about something. By the way, this is the solution, another type of solution you can use to merge the lists. Depending on which list is larger, it uses the prefix of the numbers, appends them to the merged list, and then if the first list is larger, it adds the remaining elements from that. Otherwise, it adds the remaining elements from the other list. Okay, and here's an interesting trick you can do. In Java, you can print an array converted to string directly on the console. So array.toString in Java would generate, if you have the array 1, 2, 3, it would generate something of the type 1, 2, 2, 3, or something like that. We need to test it actually to see what exactly it generates, but toString of an array generates something similar to this string over here. So what we're doing here is very neatly telling Java to replace any bracket, any opening bracket, any closing bracket, and any comma with an empty string. We're calling that over the string that Java generates for an array. So what we will have remaining is just the numbers. So if you replace every such symbol, and every such symbol in the string 1, 2, 3, closing bracket, if you replace these three symbols with emptiness, what you'd get is 1 space 2 space 3. Now, this is what you call a regular expression. This is something for another topic, for another lesson, so we won't discuss it in details here, but you can play around with it and see what it does. Okay, so before we go into a break and before we move on to the sorting lists and arrays topic, a slight modification of this task. Now, what you would usually do when merging lists isn't just merging them item by item. What is often found in computer science is merging two sorted lists. So you have the lists 1, 2, 3, let's comment this line out, 1, 2, 3, and 4, 5. And merging them, you'd want to create 1, 2, 3, 4, 5. i.e., during the merging operation, you take items from the lists, but you only take the smaller of the two fronts of the list. So this is the frontmost item of the first list, this is the frontmost item of the second list. You don't take both of them, you check which one is smaller. And if the first list's front item is smaller, then you use that and you place it in a list. And you remove it from the original list. And then you do the same check again. If the first item is smaller, if the front item of the first list is smaller than the front item of the second list, you use the front item again and you get this number 2 over here. And you repeat this operation. Here we do it for 3, we place 3 here, and then we do it for 4 here because there are no items in the first list. And then we do it for 5 again because again there are no items in the first list. So let's add some other example input. So let's say we'd have 1, 7, and 10 here, while we have 1, 8, and 11 over here. So 8 and 11 over here. What would happen? Well, we do which of these two is smaller, Well, 1 is smaller than 8, so we place 1 and we remove that 1 from the list. And then, which of these two is smaller? Well, 7 is smaller, and we remove that from the list. And then, which of these two is smaller? Well, 8 is smaller, and we remove that from the list. And here, 10 is smaller, so we remove that from the list and place it in the second list. And here we have only one item remaining, so we place that in the list. This is called merging sorted lists. Merging sorted lists. And it's a good idea to try and implement this. What would the code be? Well, while how long did we execute? We executed until both lists are empty, correct? So it would be something like, here's our merged list. It would be while number say is empty, while this isn't empty, or while the other list isn't empty. So while at least one of these lists has items in it, then if and you'd need some additional checks here. Now, it is possible that one of these lists is empty while the other isn't. So you need to check if numbers A is empty, then just add to merged the first item of numbers B. Add numbers B dot remove the first item. Remove, in addition to removing the item, returns it as a value. So you remove it and you place the value into merged. So same thing for if numbers B is empty, then you'd add from numbers A into merged. And if none of them are empty, if both still have items in them, then you'd add if numbers A get item 0 is less than numbers B get item 0, then you'd add which one of them? You'd add numbers A. So you'd get numbers A dot remove index 0 and you'd add it to the merged list. Now merged dot add numbers A. And in the other case, you'd add which? Well, the item in numbers B. Okay, so if A is less than B, you'd get the A item, and if A is larger than or equal to B, you'd get the B item. Okay, so what would we get in this case? Well, exactly this output, exactly this this merge operation on this list. Now, they have to be sorted lists. Sorted meaning ordered from smaller to larger elements. So the first elements are smaller than the last elements. And this is true for each consecutive pair of numbers in the lists. So this is called a merge operation, and it's part of the merge sort algorithm. Now, this isn't the most optimal way to implement it, since each of these remove operations will have to shift items. At least not for array lists. If these were linked lists, this would be completely fine. But it is one way to implement it, and it's part of an optimal algorithm for sorting. But algorithms for sorting we will discuss after the break. Okay, let's continue with the last part of this lesson. We're going to talk about sorting, how we do it for lists, how we do it for arrays, how we can use that for solving different tasks, and so on. So what is sorting? When you have a sequence of elements like we have in lists and arrays and so on, you can have these elements in multiple different orders, but what you can do with them, for example, if you have the items 1, 3, 2, 5, 10, minus 1, this is what we'd call a non-sorted array, at least not sorted according to the natural order of the elements inside this array or list or whatever collection it is. A sorted version of this collection would be the items ordered according to some comparison, and the natural comparison for numbers is the numbers ordered by their positions on the numerical axis. So you'd have minus 1, 1, 2, 3, 5, and 10 in a sorted array or list. This one is sorted by the value of the element in the appropriate position. So this is an ascending sort, meaning that the first items are less than the last items. We ascend up in value when we're traversing this list. So this is a sorted list. How would we do that in a normal situation if we had to implement a sorting of a list without having any knowledge of how to do it in Java? Let's try to do it. Let's try to implement a sorting function by ourselves, so we can know what the Java code which we'll see afterwards actually does. So let's have a list of integer which will contain our numbers. And these numbers, let's, instead of reading them from the console, just initialize them with some values. So I'd say a new array list containing integers, and to set its value directly, I would need to pass in an array which acts like a list here. So I'd say array as list, and I'd set some items. Let's use the items I just thought up. 1, 2, 1, 3, 2, 5, 10, -1. Okay, so this is an unsorted list. At least it's not sorted according to the natural order of these elements. You could order items by a bunch of different characteristics, but for now we will just use the natural order of the items which we have, meaning that if we have integers, we would like to order them by their integer value. If we have strings, we would order them lexicographically, i.e. according to how they would appear in a dictionary. Okay, so here are our numbers, and we want to sort them. How do we do that? Well, we need to shuffle them around in such a way that there are no positions in which an item at the current index is less than the item at the next index. Is larger than the item at the next index. So we want for each two indices in this list, for example, for index 0 and index 1, we want it to be true that getting the item at index 0 gives a value that is less than getting the item at index 1. And we want the same thing for getting the item at index 1 and getting the item at index 2, and so on and so forth, until we reach the end of the list. How do we do that? Well, how did I do it when I wrote the example when I was explaining what sorting is? Well, I kind of don't know what I exactly did, but let's think about it. If one way to think about how an algorithm works, how to implement it on a machine, is think of each item individually. Only think of a single item at a time, because computers see lists as single items at a time. They don't see them like we do the entire list at once. And even we don't actually see the entire list at once, although our mind tricks us into thinking we do. So what did we actually do? If I have to do it step by step, and I have to think of each item at a time, I know that I'll have a sequence of items, and I can access them anytime I want. What do I do to find the sorted variation of this list? Well, to start, what I do is find the minimum item, find the least item in this list, and place it at the first position. So I would go item by item and search for the minimum of this list. In this case, the minimum would be -1. I'd take that -1, I'd remove it from the list, and I'd place it at the first position in a new list. Then, guess what? I'd do the exact same thing again and again and again. So I'd go over here and search for the next least item, so the next smallest item after the one I removed. So basically I do the same thing, I search for the smallest item. So I say, okay, in this list, which is the smallest item? Well, is this one? Well, this seems to be small for now. Compare it with 3, yeah, it's still smaller. Compare it with 2, yeah, it's still smaller. Compare it with 5, yeah, it's still smaller. Compare it with 10, still smaller. No more items, so this one's the smallest. And guess what? I'd remove that one. And in my list, which contains up to this point -1, I'd add 1. And I'd repeat again, from the start of the list to the end of the list, search for the smallest item and add it to the new list. Okay, let's do that. we will implement an algorithm which traverses the numbers list. How many times would it need to traverse it? How many times would it need to visit each item and check which is the smallest? Well, it would need to do it as many times as there are items in numbers. Or if we're going to be removing items each time, well, the simplest thing would be to continue until the list becomes empty. So while numbers.isEmpty is false, while there are still items, do a loop. Do the body of this while loop. What will this body do? Well, we'll be searching for the minimum value, int minimum, and we'll say that we'll set the minimum to the first number, and then we will just try to find another minimum. So we'll say numbers.get of index 0. So we'll get index 0 and say this is the minimum. And from here on out, we will try to change it. We will see if any other element changes this this condition. If anything changes the current minimum. How? Well, we will start from index 1, since index 0 we already have here, and we will continue to numbers.size. Okay, so what will we do while walking these numbers? Well, I'll say if numbers.get the current position is less than the minimum, then the minimum would become equal to the current position. It would become equal to numbers.get of the current position. And I'd save this in a variable. And I'd call it current value. So, and I'd change this to a simple int. So, I found the minimum. And let's create another list which will contain the elements sorted, which is a new array list. Okay, so when I found the minimum once, I want to add it to the sorted list. So I'd say sorted.add minimum. And I'll repeat this as many times as necessary for the numbers to become empty. So I will move each item from numbers into sorted, but I will move them in such a way that I preserve the natural order of numbers. So each time I will place the minimum number from numbers. Now I'm missing some things here. First of all, I'm not removing the minimum from numbers. Now what I'd do here is I'd save the index of the minimum, min index. Why am I saving the index of the minimum? Well, because I want to be able to delete this index later on. I'd say min index is equal to I. Why? Well, because the minimum here becomes the current value, so the minimum index should become the current index. Okay, so what will I add here? Well, instead of using min, I can just use the remove function to remove the value from the original list, and then use the return value of the remove function to get the value added into sorted. So I'd say sorted.add, and I'd place numbers.remove the min index here. So remove the item at the minimum index, at the index which contains the minimum item, and use the item you get from this remove operation to be added to the sorted list. So I'll get a list which each time gets the minimum of the original added to its end. For initially, the sorted list will contain just one item, the minimum of numbers. Then, on the second position, the sorted list will contain the next minimum of the remaining numbers, because we've just removed the minimum. So we'll get the next minimum, and then the next minimum, and then the next minimum. Each of these will be larger than the previous, larger or at least equal. So each time at sorted, we will be adding something that is larger than the last item we have added to it. Okay, so let's see if this works. There could be mistakes here. Let's say we want to print this sorted list, and I'll use arrange for each loop for this. I'll say sorted, out and enter iterate, and I'll say for each number in sorted, system.out.print this number and print a space after it. Okay, let's start this. No, we don't want code coverage here. Let's start it in debugging mode so that if there are errors, we can see where these errors are. As in errors, I mean wrong index access and so on. Now, there's no input for this test because I already initialized my values. Nowhere do I read input from the console. So I directly received the answer to the question, what is the sorted version of this list? And the sorted version seems correct to me. Now, a few things about this sorting algorithm. It's definitely not optimal, especially since we're removing items each time. Removing an item takes time because all other items after it have to be shifted left to cover the empty spot that appears. That's one thing. And another thing is that each time I iterate this list to find the minimum, I walk through all items. What does this mean? That if I have this number of items, to remove the first element, I have to do 6 operations at least to find the minimum, to find this one. Okay, and then I have to do another 5 operations. So 6 operations here, then 5 operations to get this one, then 4 operations to get this one, then 3 operations to get this one, and so on and so forth. You get the idea. As we get the number of operations equal to the sum of the sum from the numbers from 1 to n, where n is the size of our list. So that's approximately the size of our list to the power of 2, n squared. That's not optimal. That takes a lot of time. So this is not an optimal algorithm, but it's one algorithm you can implement when you want to sort something. So it's important for you to understand what sorting does. It always does some operation which resembles finding a minimum and placing it in the appropriate position, or at least comparing values and placing them depending on the result of the comparison. So what can we do instead of using this non-optimal solution? Well, we can use the Java methods which are integrated into the Java language, and instead of modifying our original numbers and adding to another list and so on, what we can do is use collections.sort. This will do a natural order sorting of whatever we have in our list of integers in this case, but we could have a list of strings, a list of doubles, a list of bytes, a list of whatever. As long as the items in the list can be compared with one another, like strings and numbers can, this collections.sort method will order them in the appropriate order for, in this case, numbers, for the appropriate order of the data type which the list contains. So depending on what is contained in this integer list, we will get a sorting which matches that data type. Okay, so calling this sort method will give us the same result we received a few moments ago. If I add the -1, which I deleted, let's add it and start this code again. We'll wait a while, and here are our values. -1, 1, 2, 3, 5, 10. These values are now sorted in ascending order. Now, you might wonder, how can we get them in descending order? Well, there's a pretty easy way to do that, and a not so easy way to do that. The easy way is, well, we've already sorted them. We want them in reverse. And guess what? There's collections.reverse. And you supply the numbers which need to be reversed. Both of these methods change the original list. The same way that any method that works on an array can edit the original items in the array because it has access to the memory of the array. Well, the same way sort and reverse affect the original array which we are providing as a parameter to them. So what we did now was sort the numbers and then just reverse them so that when we print them, they will appear in reverse order. Of course, instead of reverse, you can just do a for loop starting from the last element and continuing to the first element and printing like that. But if you want the collection reversed without having to write loops, this is one way you can do it. Okay, so this is how you sort lists and how you reverse them. Now, if you want to play around with the sorting logic, I told you that you can sort by a very large amount of characteristics for each object. For example, let's say we want to order these items by their, not by their value, but we'd want to order these items by their, it would be weird to, let's say they are two-digit numbers. Let's say they are 11, 33, 22, 55, 10 is a two-digit number, and minus 11. Okay, so let's say we don't want to order them by their value, we want to order them by their last digit. So we want to order them here by this 1, by this 3, by this 2, by this 5, by this 0, and by this 1, and we'll ignore the sign. How would we do that? Well, the sort function can accept a comparison function, and this is going to be a bit weird, but I'll show you so you know that these things exist. So what you can provide here is a way to compare two values. In order to compare two values, you have to have two values. So let's say these values are A and B, and you need to cover them in brackets like this. And these A and B, you say they go into, this arrow means they go into, and here you can write the comparison you want. So what is the comparison we want? We want an integer comparison between two values, and writing it like this would just do the default sorting of the numbers. So if you say for each two numbers, this is how you'd read this line of code. Sort the numbers by comparing them, by using this comparison function that for each two numbers returns the comparison of the first to the second. This is the default. This is what Java uses by default if you don't provide anything. It just compares the two values in this order. How does it compare them? You don't care. You just use the comparison function and provide the two values that need to be compared. Meaning that if these two values are anywhere near each other in the array, they should be ordered in this way. A should be before B. So for any two consecutive values in the list or array, you say that A should be before B by providing them like this in the comparison. So if you want to compare them by their last digit, you do compare them by A%10, meaning get the remainder from deleting A by 10, and get the remainder of deleting B by 10. So I'm saying A and B have to be ordered like this if their last digits are ordered by this. So ordered this way. So this would compare our numbers by their last digit. So now if we change these to 21, 23, 22, or let's say 42 or 72, I'm mixing up the order of the values so that you see that we're ordering them by the last digit. Okay, 100 and minus, let's leave minus 11 by itself. So now what we'd have here is what we're comparing by the number, its last digit, the remainder when we divide it by 10, and let's put in an absolute value here just in case, mat.absolute value, so that we don't get affected by the minus sign on the minus 11 number here. Okay, so these suggestions which we get are a way to compress this this way of writing a comparator, but we don't care about the suggestion we're getting right now. But just so you know why this is in faded text, because there's a shorter way to write this comparison. But I'm writing the longer route so I can describe it component by component how it works. Okay, so let's remove the reversing and let's see what's going to appear here. We're waiting a bit. We expect them to be ordered. Okay, so what did we get? 100 is on the first position. Why? Because its last digit is 0. and then we have 21 because its last digit is 1, and then we have 11 because its last digit is 1. By the way, you'd say, okay, so 21 and 11 are the same when looking at the comparator. Why is 21 before 11? Since they have the same value when comparing them. Well, the reason is that 21 appears before minus 11 in the input. So these sorting algorithms are the so-called stable sorting algorithms, meaning that if two values are considered equal in the comparison, like in this case, because we're taking their last digit only in the comparison, so the comparison is equal. If they're considered equal, order them as they were ordered in the input. So that's why we get minus 11 after 21, because minus 11 is after 21 in the original data. Okay, and so on. We have 100 because it ends in 0. We have 21 because it ends in 1 and 11. We have 42 after that because it ends in 2, which is larger than the 1 in which minus 11 ends. Then 23 because it ends in 3, which is larger than the 2 in which 42 ends. And 75 for the same reason, because 5 is larger than 3 and 23 ends in 3. Okay, so this is a bit more complex and really isn't supposed to be part of this lesson, but I like to show additional stuff when I'm showing you a lesson, so this is one of the additional things you can do. If you didn't understand this, relax, it's completely normal. We haven't reached this part of your, let's say, career in which you will easily understand such expressions, but in not much more time you will learn to understand them, and seeing them now will probably help you further on. Okay, so this is how you sort a list, and we have examples here of sorting like that. In this case, we have a list of strings, and sorting a list of strings happens in the exact same way in which we can sort a list of numbers. So the method is the same, the list construction is the same, the only difference is we initialize with strings, not with numbers. Okay, so joining these strings together, sorting these strings together and joining them will print them in their lexicographical order, which is pretty much their alphabetical order, with some differences based on character casing and punctuation ordering and so on. So basically, if you hear lexicographical order, it means alphabetical order. Okay? So if you want to reverse them, again, you can use the reverse function the same way we did for numbers. So a list doesn't care what you store inside it. It really doesn't, it doesn't really know what you store inside it. It just knows it has items, and it returns or sets these items when you tell it to. Okay? So we have a task here, and let's solve that task. The task is we have a list of products, and they will be entered on n lines, so we know the number of products initially, and we have to print them ordered by their name. Pretty simple task. We just have to read this into a list, and then we have to sort them, because we have these items in an unsorted fashion delivered to our input. We need to get them out sorted by their name. How would we do that? Well, let's try to implement a solution for this task. So first we would need an integer number, which is the number of items. Since in the task they call it n, I will use the business terminology which they use in the task to name my variables. That's one way to figure out how to name your variables. Use the terminology you have in the task you're solving. Okay, so scanner.give me the next integer from the input, and then start a for loop starting from 0, continuing until we reach n. And what do we do with this? Well, we will need to enter products. Products are strings, and since we will have many of them, we will add them to a list. Now, we do know how many of them there are, so we can optimize the list initialization by saying this is a list of strings, and this list is the products. Again, I'm using the terminology used in the task to ease my naming of the variable, so I know what this corresponds to from the task description. And I'll say this is a new array list which contains n items, or prepare it to contain n items. it's not necessary for me to add exactly n items, nor is it necessary to add less than n items. I can then add any number of items, but the array list will optimize for this amount of items initially. So what am I going to do here? Well, I need to read the next line, which will contain the product which I'm reading from the console. So product will be equal to the next line. I'm getting that in the variable product, and I'm adding it to the products list as a product. Okay, so now I have the products added, and I have to print them numbered. Let's print them numbered, even though we don't have them ordered yet. Let's see if printing them works. So let's solve this task part by part, and then we'll implement the sorting procedure. Okay, so I need to, since I'm going to be writing prefixes, numbered prefixes here, what I do is start a normal for each loop. So I'd say products, alt and enter, iterate, for each string product in products. And I'll initialize a number, current number, or current position, or whatever. And that will start with 1. So why does it start with 1? Because in the output I've been given, the output starts with 1. Okay, so I'll start with 1, and I'll print using system.out.print formatted output, and the formatted output will contain the number followed by a dot followed by a string. So the number, digits, followed by a dot followed by a string. Okay, and what parameters do I need to provide? I need to provide the current number, and I need to provide the product which I'm printing. And what else do I need to do? Well, the current number is currently 1. But after I've printed the first product, I need to increase it so that when I'm printing the second product, when this for each loop continues on to the second product, current number will be 2 to print 2 before the next product, and then it will become 3, and then it will print 3 before the next product, and so on and so forth. Okay, so let's see if this works. I haven't implemented the whole task, but it's a good idea to test your task in stages. What works, what doesn't. If you have an error somewhere, better to catch it early than to catch it late when you have to debug an entire program. Okay, so let's say there are 4 items, and one of them is water, the other is pumpkins, and the other one is carrots, and the other one is dogs. Oops, something failed over here. What failed? Now we got 1 dot. 1 dot is empty. 2 is water, 3 is pumpkins, 4 is carrots. Why did we get such an error? Now, if you've been careful with how we read the input, right over here we did a next int. But next int reads up to where? It reads up to the end of this line, but it doesn't read the end line character. And since from here on out we're reading with next line, well, since we're at the end of the 4 digit and we say next line, what do we get from this next line? Well, we get 0 symbols, because exactly after this symbol 4 there is a new line character in the input which is not rendered. At least not rendered as this symbol, it's rendered as a new line simply, but we're in between this digit 4 and the new line symbol. So if we say next line, that just reads up to the end of this line. So it reads this empty string, and that's why we only had the option of adding 4 items here, 3 items here, even though we said we want to add 4 items, because actually the first item we added is this empty string over here. So if you're reading with next int and you know your next input is going to be on the next line, what you're going to do is say scanner.nextLine, just so you can read out this empty string at the end and go to the next line. The entire point of this next line we're calling now is to go to the next line. You don't care about the empty string here, because you know that it's only one number here followed by nothing. So you proceed to the next line using scanner.nextLine. Okay, so now if we start this, see how testing your program early can help you catch bugs if I already had the sorting or some more complicated logic added here, I would have had to spend more time searching for where the problem was. And now I know that the problem has to be either in the input or in the output, which are relatively short parts of code which I need to read and analyze. Okay, so let's see. For water, pumpkins, carrots, and dogs. Okay, so what do I have printed? Well, I have water, pumpkins, carrots, and dogs printed correctly, as they were in the input. However, I have forgotten to add the new line at the end. Another thing which is nice to find in the beginning of your code, not when you have a million other things to debug. Okay, so this adding the new line here will help us print correctly, and now we just have to handle the sorting. So how do we do the sorting? Well, you use collections.sort and you provide what needs to be sorted. In this case, the products need to be sorted, so we call collections.sort over the products. They will be ordered alphabetically, and after they get ordered alphabetically, we will iterate them one by one and print their index, the index of each one before it, and after that, that product itself, and that will give us the products numbered and ordered alphabetically. Let's see this input now. I'll copy the input I provided a few moments ago, and I'll start the code again so I can paste that input on it again. So I paste that input, I press enter, let's see what happened. Carrots is first, dogs is second, pumpkins is third, water is last. That seems correct alphabetical ordering to me, so that's our task. Or that's some subset of our task. We might have some other detail we need to implement, but that's the gist of the task. That's the main part you need to solve. Okay, another task we have, and then we'll be finishing up. We have a list of integers, and for these integers we have to remove the negative ones and print the remaining elements in reversed order. So we will have to use the reversed method we just saw, and we will have to in some way remove the negative values. Now, how would we do that? Well, we already had a similar task where we had to remove items. Now, since we're removing items, and since we'll be playing around with indexes, again, I will be using the while loop, not the for loop, because using the while loop gives me more control over the index which I'm accessing. Okay, so what do we have? We have a line of numbers. Guess what? I have a function, a method, which reads a line of numbers. I just have to say scanner.nextLine, read the next line, and pass that on to the parseNumbers method, and get the result from this. These are my numbers. I get them in this list of integer numbers, and now I just have to clear the negative numbers from them. Now, of course, I can just iterate the numbers and print them on the console, but that won't give them reversed. I need to first remove the negative numbers, then reverse what's left of these numbers, and then print them on the console. How would I do that? Well, I'll create another index variable, and I'll say, while this index is less than numbers.size. Again, you remember as with the first task where we had to use a while loop, I just create a loop which iterates up to the end of the list I have to iterate, and then I figure out how to modify it to implement the task at hand. So this is how I would iterate the numbers list. This is how I would pass through all the items of the numbers list. And now, if the current item is less than 0, if numbers.get out of I, so numbers.give me the element at position I, if this thing is less than 0, then I'd have to do something. What do I have to do? Well, I have to remove that item. Okay, so I have an I++ here. Should I or should I not do I++ every time? Let's think of an example. Let's have 1 minus 2 minus 2, 3. Okay, if I is 0, so I equals 0, position 0 is the one here. So I come here, I see that this isn't negative, and I do I++, I becomes 1. Okay, so I see that this element now, I is equal to 1. I see that this element is negative. So I need to remove it. So removing it, what happens? 3 comes over here at index 1. And what will I do? I would increase the index by 1. In the current code, that's what I do. I always increase the index by 1. And I'd get the index 2. But since 2 is now larger than the number of items in the list and larger than numbers.size in my code, I will not execute the loop anymore. So I will have in numbers 1 and 3, which seems correct. However, let's think of another example. What would be another example in this case? Well, another example would be what happens if there are two negative numbers next to each other. So I have 1, minus 2, minus 3, 4. What would happen in this case? Again, I go to index 0, nothing happens. I go to index 1, I remove this number, I move which moves minus 3 to index 1 and 4 to the index of the previous index of minus 3, which is index 2. And what happens? Since I was at index 0, now I'm at index 1 and I'm removing index 1, meaning that at index 1 there is new data, which I'm not seeing because I'm always doing plus plus, meaning that I'd go to index 2, which is now the value 4, because it moved, and I'd miss the new value at index 1, which is the value minus 3. So whenever you're iterating a list, just like in the previous task, and you're removing items from it, keep in mind that if you're removing the current index, you probably shouldn't continue to the next index because there is new data at the current index, and you need to process that data too if you're intending on processing every item in the list. Okay, so we will only increase the index if we haven't removed an item. So if we remove an item, we stay at that position because a new item has arrived in that position, and that item might be negative also. And in all other cases, we just increase the index. And of course, we need to print these numbers. We'd say numbers, alt and enter. We'd iterate these numbers, and for each number, we'd system.out.printf and say print a number here with a space following it, which number? This number from the for each loop. Okay, so this prints our numbers on the console, and we can test this code and see how it works. I won't play around with this now for several reasons. First, I haven't reversed these numbers, right? In our task, we had to not only remove the negatives, but also reverse these numbers. So from this input, we need to remove minus 2, remove minus 10, and then reverse 1 and 7, giving us 1, 7 instead of 7, 1. Okay? And also, if this list was empty, I'd have to print empty instead of just an empty line. So this I'm leaving to you, but just as a reminder, how would we reverse them? Well, we'd use collections.reverse and pass in the numbers list. So this would reverse them, and what's left for you is to add a condition which checks, well, if these numbers are empty, then print empty as a string, and in the other case, just do this for loop printing. Or you could solve it a million other ways, as in most programs, but this is probably the tightest way you can do it. Okay, so that's this task, and here's another solution of this task. Note that most of these tasks are single line read from the console using the Stream API, but again, if the Stream API is weird for you for now, you can just use the methods which we implemented. Okay, so here the solution is done by using for loops. The for loop just iterates the numbers, and if it finds that it needs to remove something, it moves the index back, because each time we reach the end of the loop body, the index will move forward, so moving it back and forward will leave it in the same spot where we removed. So again, this is, I prefer the while loop because there's no jumping around of the control index, of the control variable of the loop, but if you prefer the for loop, that's fine too. Okay, so what we talked about today was that lists are a variation of arrays which hold sequences of elements, but in addition to that can change their size by using the add, remove, and insertion, although insertion is called add with the parameter index and value. So inserting is just adding at a certain index. We saw that in one of the examples in the start of the lecture. So lists are basically your go-to collection for most cases. There are very little situations in which you'd prefer arrays. The reason you'd prefer arrays is because they are slightly faster and they're slightly less memory intensive than lists. So if you know the exact number of items in your input, and you know that you won't be needing to remove items or add new items, then you can use an array. But in all other cases, you'd probably be best off using a list. Okay, so how do we create a list? The list type we are using currently is the array list, and this array list is created by just typing in new array list and assigning that to either a list of something or an array list of something. Both of these would work, but I'd suggest you get used to the syntax list out of some data type, then add your list name, and then say equals to new array list and close the brackets. This isn't exactly very visible, but you get the idea. Okay, so this is how you create a list, and every other operation which you have in an array can be done in a list. So when you have the array operation give me the index at I, that's equivalent to the list operation get from I. If you want to say the element at index I is equal to something, well, that is the equivalent of saying set at index I the element, for example 42. If this was assigned it to 42, well, this code matches this code for lists. Okay, and you can join string lists into a sequence of into a string sequence by using string.join. You can't do this for numeric lists in Java, but there are ways to implement methods which can do it for any type of list. We will study them further on. Okay, I have to remind you that you can ask your questions in all the channels you have been provided, Facebook group, Slido, and so on. We'd be happy to answer them, and thanks for listening. I hope this was useful for you, and see you next time.
Did you like this lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free video tutorials on coding and software development. Get free access to the practical exercises and the automated judge system for this coding lesson and many others. Get free help from mentors and meet other learners. Join now, it's free. softuni.org